Alright, so quadratic with known roots. So we're going to do the opposite of what we have been doing. You're going to be given a quadratic, or you're going to be given the solutions to a quadratic, and then you have to come up with it. So basically it's the backwards version of something that we've been working on. So for example, say I had x squared plus 5x minus 14 equals 0. If you had to solve that, one way to do that would be to factor. And the factorization would have looked a little like that. And then we would have said x is a negative 7 is one solution and x is 2 is the other solution. Okay. Well, now I'm going the opposite way. If I give you the negative 7 as an answer or as a root, then x plus 7 is the factor that goes with it. And if it's x equals a positive 2, then x minus 2 is the factor. So if x equals 1 is the solution or the root, then x minus 1 is the factor. And if x is a negative 3 is an answer, then x plus 3 is the factor. Then we tend not to leave it in this factored form here because we do want to see it sort of in like the quadratic form. So that's x squared plus 3x minus 1x. So that's x squared plus 2x minus 3 equals 0. So that's the principle behind this. Okay? It can get a little more difficult. We can have fractions, for example. So here's with fractions. So if a half is the answer, then minus a half is the factor that goes with it, and x plus 2 over 3 would be the other factor. But we can't leave 3's and 2 over 2's in the factored form, so we have to get rid of all the fractions. So the way that you can get rid of the over 2 is to multiply all of the parts here by 2. So we're going to basically multiply inside the parentheses by 2. So you would get 2x, and then this 2 and that 2 cancel, minus 1. So here you would multiply by a 3 on the inside. So you would get 3x plus, and this 3 and that 3 cancel, and that's 2. So some people call that like the slip and slide method. You just slip the 2 in front and the 1 slides down. You slip the 3 to the front and the 2 slides down. Okay, that's not too bad either. We do need to multiply this out. So we would get 6x squared plus 4x minus 3x minus 2. So the final answer would probably look a little like this. Okay? Well, what if you have this kind of a mess? Well, first thing is that this does show that we have two answers. So we're going to consider this and that as a value, which it is. We just don't know what 2 plus the square root of 7 is. But it gives you the following. So if 2 plus the square root of 7 is an answer, then x minus 2 plus the square root of 7 is the factor. And on this one, it would be x minus 2 minus the square root of 7. So both of these end up being subtraction. Okay, and then we have these weird double parentheses. So let me distribute that. Negative. So keep in mind that it could think of this as like a negative 1 here. So I'm distributing a negative 1 across. So we end up with a negative 2 minus the square root of 7. And you end up x minus 2 plus the square root of 7. Okay. Now the long way here would be to multiply it out. So we're going to do x times x, which is x squared. You're going to do x times a negative 2, that's a negative 2x, and x times the square root of 7. So that's plus x square root of 7. Then the negative 2 times the x, that's another negative 2x. And then a negative 2 times a negative 2, so that's plus 4. So that's on its own right now. And then a negative 2 times the square root of 7, so that's minus 2 square root of 7. That's getting to be quite a mess. So then it's a negative square root of 7 times x. So that's minus x squared root of 7. And it's a negative times a negative, so that's plus 2 times the square root of 7. And then a negative square root of 7 times a positive square root of 7, that's, let's see, a negative square root of 7 times a positive square root of 7. So that's actually the square root of 7 times itself, so that's 7 with a negative. So that ends up giving you this. So finally, then you get x squared minus 4x, those cancel, plus 4 minus 7, which is plus 4 minus 7 is minus 3, and those cancel as well. So that's your final answer. You can certainly do it that way. There is a shortcut to this. So let me start from the point where you can sort of see this shortcut. So it's x minus 2 minus the square root of 7, and then it's x minus 2 plus the square root of 7. So I'm basically back at this line. Okay. All right. So what is happening here is actually the following. This is a conjugate pair. And the conjugate pair is basically the a minus b times a plus b pattern. So we call that the difference of squares. So what you have here is x minus 2 minus the square root of 7. So that's the a minus b, with a being x minus 2, and b is the square root of 7. And then here we have a plus b. Well, if you multiply this out, you know that you should get a minus b times a plus b is actually just a squared minus b squared. And that's what I'm going to do. I'm going to do a squared minus b squared. And that saves me a whole bunch of multiplying. Now I still have to multiply x minus 2 squared out, because that actually means x minus 2 times x minus 2. So that is x squared minus 4x plus 4, and then I'm subtracting the square root of 7 squared, so that's minus 7. So that's that 4 minus 7 over here. All the other stuff here is taken care of by sort of the canceling because of the conjugate pair. So finally we end up with the same answer, x squared minus 4x minus 3, and that's supposed to equal 0. Okay, so there's two ways to do that. So that's sort of the annoying problem. Then the easiest problem is this. If I told you, and remember we're working on quadratics, so if I said I have a quadratic and the roots are x is a negative 4, and that's the only root that I'm listing, then this is where you have to keep in mind that that's the term the double. So x minus 4 here, x minus 4 would be an x plus 4. If that's the only one listed, it must be a double. So x plus 4 squared, which when you multiply that out gives you x squared plus 4x twice, so that's 8x, and 4 times 4 is 16. So here's the quadratic that has a negative 4 as its only answer. And that's it for today. Thanks.